What is digital forensic? It is the branches of forensic science encompassing the recovery and investigation of digital exhibit and presenting it to the court. It is the recovery and investigation of material found in digital devices open relation to computer crime. This can be obtained in document, picture, audio, and file. And now, let's enumerate the importance of digital forensic. The cyber criminals are getting smarter, handling sensitive and confidential data, maintaining integrity of data, preventing data corruption, staying within the law and rules of evidence. And now, let's move on to the 5 phases of digital forensic. We have identification, preservation, analysis, documentation, and presentation. Phase 1, the identification. It is the first step in forensic process. The identification process mainly include things like what evidence is present, where it is stored, and lastly, how it is stored. Phase 2, the preservation. In this phase, data is isolated, secured, and preserved. It includes preventing people from using the digital devices so that digital evidence is not tampered with. Phase 3, the analysis. In this step, investigation agents reconstruct fragments of data and draw conclusions based on evidence found. However, it might take numerous iterations of examination to support a specific crime theory. Upon analysis, we should conduct comparison, detection, verification, filtration, enhancement, and decision-making. Phase 4, the documentation. In this process, a record of all visible data must be created. It helps in recreating the crime scene and reviewing it. It involves proper documentation of the crime scene along with photographing, sketching, and crime scene mapping. Phase 5, the presentation. In this last step, the process of summarization and explanation of conclusion is done. And now let's move on to hashing algorithm and its application.
For this lesson, I'm going to cover what is hashing. A hash is a fixed size string of numbers, for example, 128 numbers. A hashing function can take any file, such as a text, audio, video, program, etc., and produce a unique hash based on that file. The resulting hash is a string of numbers unique to that file. Even a small change in the file will produce an entirely different hash value. A hash is similar to a fingerprint. Fingerprints are unique shapes on people's fingers that uniquely identify them. Hashes work in a similar manner. Hashes uniquely identify files. For example, let's say you had a text file with the word password in it. If you ran it through a hashing function, for example, MD5, also known as Message Digest Algorithm 5, it would produce a specific hash value. If you change the text file so that it had the word passwords with an S at the end, it would produce an entirely different hash. This is because the file is different. It has its own unique hash. You've probably seen a hash value when you downloaded a piece of software on the internet. Software producers post hash values so that users can verify the integrity of their software. For example, after you download a piece of software, you can calculate its hash value. If this hash value matches the value on the website, then you know it's not been tampered with. If it does not match, then you know you shouldn't download it. Alright, let's use the MD5 hash generator and type the word password in the string field. This is the MD5 hash value that we get. Alright, let's add an S at the end of password and see what happens. Notice that our hash value has changed. Let's do the same thing on the secure hashing algorithm hash generator. Okay, this is the hash value that we get. Alright, let's put an S at the end of passwords. Notice that our hash value has changed. Alright, there you have it.